Hello, we are Team 4 and our project is Data Anonymization and Analytics Visualization. We are working with the Platform for Enhanced Analytics and Computational Healthcare Group, also known as PEACH. They are based at University College London Hospital. This project has two rather contrasting primary objectives. They are to extend an existing data anonymizer tool and to further develop PEACH's core analytics system by providing a visualization solution. Firstly, a data anonymization tool is a piece of software which anonymizes sensitive patient information for use in various areas of research and statistical records. Whilst it is important to remove any identifying information from sensitive medical data due to privacy and legal reasons, it is also vital to maintain enough detail for use. Currently, there are no effective and extensively tested anonymization programs in use by PEACH today. The core analytics system provides a modern data analytics suite. This would support routine care, business intelligence, and research. Currently, there are many commercial offerings, but the cost is often the barrier to adoption. Therefore, the PEACH analytics system would provide a low-cost solution which allows applications from different domains and different hospitals to exchange meaningful data. We joined this project with a completed infrastructure of the system, but currently it lacks a visualizer to display all this data. Thus, a solution is required to provide a clear and usable interface for doctors and medical professionals. It is important to create a visualization tool tailored towards users so that they can maximize the effectiveness of the system by being able to process huge amounts of data quickly and accurately. We have agreed upon the following requirements with our client. Here are just a subset of the requirements, ones which we feel are the most important points. When beginning to undertake this project, we began with research of existing technologies and solutions. There were various different anonymization software. Some are proprietary, while others open source. Each has its positives and negatives, and after considering the existing tool at PEACH and its implementation stage, we were able to compare these existing pieces of software. We were able to quantify these different programs by assessing how open and structured the code is and the effectiveness in applying advanced mathematics and statistics to anonymize data. Whilst researching existing anonymization tools, we were also finding different possibilities for data visualization. We looked at various open source and commercial software programs that could be easily integrated into the existing core analytics system. Between these, we made decisions on which allowed for enough flexibility required by the user, as well as what provided a user interface tailored for the target audience. After carrying out research of existing solutions, for data anonymization, we decided on applying the Java ARX library into our project. The ARX library is open source and includes many privacy models which meet anonymization standards. The biggest advantage is that the existing tool at PEACH applies basic aspects of the library, so it would be suitable to use it to further development of this software. Furthermore, since the anonymization tool has to be run locally on computers, written in Java, this solution is able to meet the requirements. Although it does have all this functionality, it does also have a complex UI, which will require training and advanced knowledge of anonymization to use it effectively. We have decided, therefore, to rewrite the user interface to provide one designed specifically for the target audience. Next, with the core analytics, considering the existing solution with Apache, Kafka, NiFi, and Spark, we have decided that Kibana and Elastic Stack would provide the most effective data visualization tool. Not only did our client suggest this technology stack, but this piece of software is both open source, and the result has a less steep learning curve compared to other existing technologies. Carrying out user research allowed us to tailor a user interface specifically for them, and we are also considering functionalities to increase accessibility. We designed multiple prototypes for the user interfaces for our system, as shown here. Since the data anonymization tool will be run locally on users' computers, the executable will be stored on a server, and users will be able to download and install the program to use it. To test the solution, we aim to use various code testing techniques, including unit tests, tests where small samples of data is processed, and a comparison carried out by eye. For the data visualization aspect of the project, we plan to test this solution by carrying out unit testing as well as integration testing with the core analytics system. Scripts will be written to automate deployment alongside the existing solution, and various other technologies have yet to be considered to aid deployment, including Docker containers. Finally, we will be able to carry out user testing to ensure that both the anonymizer and visualizer is most suitable for the target audience and be able to complete all the tasks required. For the data anonymization, since it runs locally and is written in Java, with the Java virtual machine, most common computers will be able to run the program. However, it may require infrequent maintenance of the program in the future to fix bugs or to implement new privacy models into the program. On the other hand, the core analytics system requires a computing cluster to run the entire stack. These servers will incur a monetary cost, and it is difficult for us to estimate the total cost since we are only undertaking a subset of the system. The majority of it is dependent on infrastructure. Furthermore, it would also depend on the number of users and the amount of data being processed by the entire system. In the future, we see our project used across the healthcare industry. Not only would this provide cost savings with data analytics, but also with anonymization. However, there will be dangers with these systems. When dealing with patient data, it is very important to maintain confidentiality throughout the entire process. Additionally, with the cluster running the analytics system, with a growing number of users, there may be scalability issues, which can be solved by ensuring the system is supported by suitable infrastructure. This will be able to deal with huge amounts of data and users. On behalf of Team 4, thank you for watching.